Open up this paper. There are two sides to it. Go to the side that says on top exponential functions, okay? So we will do this one, exponential growth and decay, second, but let's do this side first because this side is easier, and then we'll do the back side after, okay? So since today we are just practicing, really reviewing, remember you can use all of these notes if you want to for your actual Edgenuity quizzes, if you feel like that would be helpful. But maybe it's also a good time for us to maybe earn some candy if you want candy. Now, online kids, if you would like to participate and you normally come in person, remember you can always remind me that I owe you candy. I'll give you candy, okay? I trust you. I know you wouldn't lie about it, it's just candy. And then if you are just online, but you're never coming back, you don't think, then just know that you took candy away from someone else. Sometimes that's all that matters. Getting into the holiday spirit of stealing from other people. It's the best. And you have all the pink ones. I only save the good colors for the kids I like, Jack. So of course you can have all the pink ones because pink is the worst. All right. I know, reds and pinks. Those are the best. All right, here we go. So if you don't have a calculator out, please take out a calculator. Let's get started. Ladies and gentlemen, exponential functions. Let's start from what we were doing on Tuesday, okay? Back to the basics. When we have exponential, here's my main equation. Y equals A times B to the X power. Remember, A is always going to be your initial value or your Y-intercept, but they never say Y-intercept because you have word problems. So they'll say like in terms of a, real life situation. And then B is going to be your multiplier, like how much are you multiplying by? So here's my function. It models the length of a photographer or a photograph in inches after the photo has been enlarged by 50% X times. All right, what is the length of the photograph after it has been enlarged 4 times? So maybe not tell me the answer, but does someone in person think they know what do we do? Like, how do I find this answer? What do I have to do? Hey, Mason. Jack, go for it.
6 parentheses 1.5 parentheses to the 4th power.
Yeah, so X means X times. They're asking me, what about 4 times? So all you're doing is plugging it in. Jack, come on up. So my answer, it looks like it would be 30.375. So do you see what I did? I just read the problem. I plugged it in. They're not asking me to write an equation. And then just go. So I have f of x equals 6, 1.5 to the 4th power. If you guys are eating your candy, please just make sure the wrappers go in the trash. That's all I ask. And your mask is on. All right. So 30.375. This is a real world problem. So I do need units. So is it like feet? Is it puppies? Is it humans? Is it what would it be? What do we think? Read? Inches. Good. Okay. So that's letter A. Now it says letter B, graph it. Okay. Does anyone remember, how do I graph something like this? Because I really just can't do it by hand. Vaughn, what do you think? Yep, so just plug it in your calculator. 6 parentheses 1.5 to the X power, just like that. And then remember, so it's going to look like this, but I can't just go, that's my answer. No, right? You need to at least have 3 dots. So go to your table, second, and then table, and then copy down at least 3 points, okay? Any 3 points will do. So like 0, 6, it's like way down here. It's basically at 0 if I'm counting by 50s. Okay, so maybe I don't want to do 1 because it looks like it'll be a straight horizontal line. So maybe like 6, 68. So maybe it's like around right there. And then maybe I'll just spread it out a little bit just so it looks more like a curve. But honestly, you can do whatever you want to. I'm doing 0, 6, and 10, but you can choose whatever numbers you want to and still just make it shaped like a curve. 10, 345. So that's how mine looks. Yours should look similar, but it doesn't have to look exact as long as you have 3 exact dots. Yes, Reed?
So how did you enter your y equals? Because mine was different.
Okay, so I went y equals.
No,
you
I
type-
know, I want to know like the equation that you entered in. I tried to enter it and it like turned into.
Did you enter it in with a 4 in it or an x?
I entered it in with a 4.
Okay, so like that, this is a completely separate problem, right? You're not graphing it with the 4, you're just graphing it in general. So that's why you have to graph it back to its original with the x.
Thank you.
Yep. Okay. So hopefully this is not too bad yet. Okay. This is a good review for our Edgenuity quiz that we're going to take later today. Number 2, a population of 550 rabbits is increasing by 2.5% each year. The function blank gives a population of rabbits in hundreds X years from now. So X stands for years. How long will it take the population to reach 600 rabbits and then 1,200 rabbits? Okay. Do you see how this question's a little bit different? They're not asking me to plug in 600 and to plug in 1,200 because X stands for years. This is not 600 years and 1,200 years. Like, this is the answer. They're asking me, what is X if the answer is 600? What is X if the answer is 1,200? I don't know. Grayson?
Well, you like say how we get there?
Sure. How do you get there?
Okay, go to y equals and then plug in the equation and then second table and find 600.
Okay, so let me repeat what Grayson said because he is spot on. So Grayson is saying, I want to know if the answer is 600, what is X? If the answer is 1,200, what is X? Well, I can't like plug it in because I don't know how to solve things like that. I've never solved it before. I've never learned how to do that. So Grayson is saying, put it in your y equals and then go to your table. Because look, here are the answers and here are the X's. So I could just try to look for it on my table. Now here's the issue. Like if my answer is 600, well, 600 is the Y, right? Should I scroll all the way down for 600? That would take me forever. What am I actually looking for then? Luis?
So you look for 6.00.
Yeah, you would look for 6.00. Do you see how right here it says it's rabbits in hundreds? So 600 rabbits is actually just the number 6. 1,200 rabbits is actually the number what? Read? 12, because 1,200 is 1,200, right? So I'm actually looking for the number 6 and the number 12. So the number 6 would be about at the 4, right? It's not quite 3 because that's 5.9. So the number 6 would be the 4. So I would say it would be 4 years for that one. And then keep on scrolling down. 32, you said? I don't even know. Oh, I passed it. 12. Okay, yeah, so 32, right? Because 31 is 11.82. So 12 is 32. So that would be 32 years. So the tricky thing about this, guys, is it's not always just plug and chug anymore. You kind of have to like read your situation to see what you're trying to look at. All right, Grayson, Luis, and Reed, come on up. You can grab candy. Thank you. Okay. This is going to be for online kids now, okay? So perk up, guys. Number 3, the function blank models the balance on a customer's line of credit X days after the end of the grace period, the time when no interest accumulates. So X stands for days. If Jack does not make any payments, determine Jack's balance 30 days after the grace period ends. So someone online, can you unmute yourselves and tell yourself or tell us, how do we find this answer? What do I do?
You plug in 30 as the X.
Thank you. Because it's 30 days. And look, it says X is day. So this time it's not like this problem. I'm not working backwards. I'm just plugging in 30 as my X. Thank you. So I have Y equals 200, 1.0004 to the 30th. All right, someone else online. I hope you have calculators at home. If you don't have one, then use your phone calculator, that app, Calculate 84 or Wabbit EMU. Can someone else online tell us how many dollars that is and how many cents?
202.14
Thank you, guys. That is perfect. Thank you. Okay. Next one. Number 4, the function blank models enrollment in a high school where X is the number of years after 2005. Use this model to estimate the enrollment in 2013. So X is the years. So here's the year. So I am going to plug it in my calculator. Y equals 2,300.995 to the X power. Do I plug in 2013 for X? No. I mean, that kind
Plug
of
in
plug in what?
8.
8. Wait, how did you get 8? Because you're right.
13 minus 8 is 5.
Okay, so this is what Kip is saying. X is the number of years after 2005. So 2013 is how many years after 2005? I don't know, 2005, 6, 7, 8, 9, 10, 11, 12, 13. It's 8 years after 2005. That's why you're plugging in 8. Rowan?
So, with, after plugging that in, you will get
2,209.59.
209.594.
Good. And then, but we're talking about people.
2,210.
Yeah, 2,210, or honestly, you could say 2,209. Guys, on a STAR test, I mean, it's multiple choice, right? So if you're like, I don't know, is it 2,209 or 2,210? It's multiple choice. They're not going to have both options unless it's like very obvious that you can't have one over the other. Now, on the STAR test, there are questions that's not multiple choice, but normally for the questions that aren't multiple choice, I'll give you a hint. The answers are like clear, like either it's a whole number or it's like a happy decimal. It's not something very like that you kind of have to think about it like that. Yes, Reed?
Well, the baby count is 0.5.
What a baby count is 0.5. A baby is still a person. You know, a baby is not half of a person. Half of a person is literally taking an axe and chopping them in half. So no,
So in this case, the school decapitated a few people.
not just a few people, just one person. Well, actually 0.45 of a person. So they probably cut off like maybe, no, not a leg. That's not 45% of you. Maybe 2 legs, but they kept like your hips or something. All right, Rowan, come on up. I don't know where this conversation took us, and I'm a little scared right now. Okay,
It's fine.
let's go to the backside. Let's go to the backside. Let's go to the backside. We're gonna skip the rest of the front, guys. Okay, we're just kind of. I just want to make sure you guys are doing okay. Can we please do number 3? Sure, but let's do number 1 first. Okay. Number 1, a condo in Austin, Texas was worth $80,000 in 1990. The value of the condo increased by an average of 3% each year. Write an exponential growth function to model the situation, then find the value of the condominium, the condo, in 2005. So we're answering 2 things. So guys, do you see how this is something different now? It's not this equation anymore. Okay, it's this one where you have f of x or y, right? Y equals f of x equals, same thing. A parentheses, 1 plus or minus. It's not always plus or minus. It's a plus or it's a minus. You decide. R to the t power. Okay, so this is the equation you're using now. You know that you're using this equation because now it's saying like increasing, decreasing by this many percent. Right? The front side, it didn't say increasing, decreasing by that many percent. So you knew that you could just use the basic formula. All right, Emily, yes.
Oh, wait, which one do I answer?
So write the exponential growth function. So write the equation. Go.
Y equals 80,000 and this is 1 plus 0.03 x.
Perfect. So do you see what she did? 80,000 is your A. It's always how much you start off with. Then you have parentheses. 1, it's a plus, it's a plus, it's a plus because you're increasing, not decreasing. And then 3% is 0.03. You don't know the year yet because it didn't tell you. You haven't gotten to that last sentence. Good job. Okay. Now, then find the value of the condo in 2005. So we're actually plugging in a number here. Cooper, go for it.
15.
Why would you say 15?
Is between 1990 and 2005.
Yeah, so you're not just plugging in 2005 as your X. You really have to read. It says, oh yeah, well, you just can't plug in 2005 because it's not 2005 years. If that's your starting point at 1990, then how many years after 1990? So that's why Cooper said it'd be 15. Cooper, did you plug that in your calculator yet? Okay. Vaughn, go for it. Awesome. Thank you. All right, ladies, come on up. You can grab candy. Okay. Number 2.
No. Oh, I plugged in the other one.
Markia deposited $500 in a savings account. The annual interest rate is 2% and the interest is compounded monthly. Write a compound interest function to model this situation, then figure out the balance after 4 years. I'm not using this formula anymore. Remember how there was one more formula yesterday? Okay, so that one more formula, and you know that you're using the different formula because you see the word compounded. Okay, that's how you know it's different. So Rowan, what is the formula?
A equals P, then parentheses, 1 plus as N. Oh, hey, wait, is it R over N or?
Yep, R over N.
R over N to the T.
Close, not to the T. Yep, to the N times T. Good job. Okay, so somebody online, someone other than, I think it was Kip who was talking over and over. Someone other than Kip, tell us, what are the numbers I plug in? A equals.
Y.
What?
A is Y, right?
Yeah, so A is Y. So I'm just going to leave it as A, but you can write Y. It doesn't matter. Okay, keep going. So now it's P.
500.
Thank you. Parentheses, 1 plus, what is R?
0.02.
Thank you. Okay, here's the hard one. What is N? Everyone always forgets what N is. What is N?
12.
12. Okay, so please remember, N stands for how many times a year? If it says compounded monthly, there are 12 months in a year, so it's 12 times a year. And then N we said was 12, and then times T. Good. Okay, now it looks like we want to find the balance after 4 years, so I'd be plugging in 4 for T. Okay, plug that in your calculator. It is a monster of a problem, but hey, guess what? You're not doing any of the thinking. So guys, what I normally say is your calculator is only as smart as the human, right? So if you're mistyping it, then of course you're gonna get the wrong answer. So go slow. It is not a race. If we were gonna calculate race you, well, I would win anyway, so don't worry about it. I used to calculator race my kids like nitro type, but on the calculator. And they all thought that they would like beat me because, you know, they're fast on the field, but I'm fast with my fingers. Owen, go.
541.607.
So 0.607, but it's cents. So you can't. 61 cents, 60 cents. I would really say 61 cents as well. Owen, come on up. Good job. Okay. All right. Reed has been dying to do number 3. He like can't handle himself. Okay. So Reed, this one's all you, kid. All right. The population of a small Midwestern town is 4,500. The population is decreasing at a rate of 1.5% per year. Write the exponential decay function and then find it after 25 years. Okay. Reed, which formula am I using? The blue one or the green one? Yes, because remember, I'm only using the green one if they say compounded, and nowhere in here is there like money and compounded. Okay, so I'm using that top one right here. So I have f of x or y equals, all right, Reed, what is A? Okay, parentheses. 1, Reed, is it plus or minus? Why is it minus? Yes, and also because it says decreasing. Okay, Reed, what is R?
Is it 15? Oh, yeah.
Well, okay, so here's the big problem that you guys had yesterday. You guys saw in your level work, oh, 1.5%. It's already a decimal, so let's just write the decimal. No, guys, if you see the percentage symbol, that means it's not, you haven't changed it to an actual decimal yet, okay? You still have to go backwards 2 times, so it's 0.015. Okay, so just because you see a decimal in your percent doesn't mean that you don't have to convert it. You still have to convert it. And then to the T. Okay. So now read after 25 years. What do I do to solve that?
After 25 years.
Yeah.
You plug in 25 into the T and solve it.
Exactly. Plug in 25 for the T and then solve it. Reed, did you do that yet? Okay, so let us know. I'm just gonna write F of 25 because that's like me plugging in 25 for X. We're talking about people, so we don't want, you know, chopped off legs.
An error.
Oh, okay. Look at your screen again. You probably typed something in wrong. That's okay.
Now I typed it in right.
Then it shouldn't have said error. Emily, what'd you get?
3,084.
Yeah, you should have gotten 3,084. Reed, do you see what you typed in wrong?
No.
Okay.
Got that typed in.
No, hold on. So bring it over here. Emily,
No, I
Reed.
typed it in right.
Oh, you did type it in right.
Yeah.
So you got 3,084? Are you lying to me?
No, I'm not.
Okay. 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 All right. Come on up. Reed and Emily, you can come on up. All right. Did that just make your day doing number 3?
It did.
Yes, I'm so glad. Okay. One more thing. So now, guys, this 5 through 9, I'm going to teach you something, and it's like kind of confusing. It's completely different. I'm not going to test you on it. You're actually going to do this math when you get to, I think, maybe chemistry in high school, not chemistry in 8th grade math, because that would just blow like all of the 8th graders' minds. But since you are in algebra, pre-AP, this is kind of like the pre-AP part of algebra. So like if you took algebra academic at the high school in 9th grade, we would not talk about this because that would blow their minds. But I feel like maybe we can handle it. So let's just talk about it. It's not going to be tested. You don't have to know it, but it's kind of interesting actually. Okay. So half-lives. There's this concept called a half-life. So it's kind of like saying, I'm recorded right now, but I'm not going to say anything completely school inappropriate. Let's say that you're like taking drugs. Okay. I hope you never do bad. But let's say you like take drugs. Okay. So it's in your system, right? It's in your bloodstream. So drugs and these chemicals that you're putting out there in your body or anywhere. I mean, it's not just drugs. Or like these, you know, radiation. Let's say that if, you know, you unfortunately know someone that has cancer and they have to go through radiation treatment, all of these chemicals that you're putting in your body, they don't just like go in your body and then disappear later, right? There's always a little bit left in your bloodstream, in your system. That's why like a month later, someone can drug test you. And a lot of times, like the heavier doses of drugs, they can actually like detect a little bit in your system, okay? So that's something called half-life. Rowan, give me 3 more minutes, okay? So what a half-life is like, let's say you take like 50 cc's of this chemical and it's in your bloodstream. Well, then its half-life would be, well, then when would it turn to be 25? Then when would it be turning to 12.5? Then like, when would it be half of it? That's what a half-life is. Like, you see how if you keep on taking a half of something, it's never going to fully disappear. Like there's always going to be a tiny, tiny trace in your bloodstream. So let's say you start with like 100. Okay. So half of it would be 50, half of it. So it like normally these chemicals, they say, when is its half-life? Well, do you see how if I keep on, oh no, let me go backwards. If I take this and then keep on dividing it by like take half of it, do you see how it never gets to 0? Like it'll just get smaller and smaller, but it will never actually get to 0. So like, yeah, in, 6 months, it'll be out of your bloodstream if you take a drug test, but realize that it actually never gets out of your bloodstream. Okay. So that's what a half-life is. Yes, Rowan.
So all sorts of fun things that have to do with half-lives is that when something that is radioactive splits and or decays, as it's called, and as part of the half-life, it spits out radiation, and that isn't so good, especially gamma radiation, which will straight up go through your DNA like a 9mm bullet through a clock.
You're right.
Oh,
Rowan, I feel like this is like your bread and butter. All right.
Yeah, and also a fun fact: the element with the shortest half-life is acetine, and in the words of one scientist, the stuff just plain doesn't want to exist.
Exactly.
Like its half-life is measured in fractions of a second.
Yeah. Good. All right. Thank you for learning, all of us. So half-life is exponential. It's just going exponential down, 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 down. Okay. Now there's a new exponent. Well, it's not really that new, but let me just talk about it. So write this on the side of your paper. It's P or A equals P parentheses 0.5 because it's a half-life. So it's always half, right? So you're always going to have a half there because it's the half-life. When does half of it take away? To the T power. Okay. So half-lives range from less than a second to billions of years. That means that depending on what the chemical is or the whatever you want to call it is, sometimes it takes less than a second for it to lose half of itself, or sometimes it takes billions of years for it to lose half of itself. Okay, it just depends on like the chemical or the whatever you want to call it. Yes.
So,
Okay.
speaking of
So hold on, Rowan, why don't you tell us after, okay? Because I feel like I still want to give you some edgenuity time too, okay? All right, the table below shows the half-lives of several substances. Select your best answer. So for this one, number 5, about how many grams of a 500-gram sample of technetium-99 is left after 2 days? So they're saying, I have technetium-99. I have 500 grams of it. How much of the 500 will be left after 2 days? So this is what I think to myself. I plug it in this formula. A equals P. Well, the number outside, I haven't told you what P stands for yet, but you should always kind of like, I mean, based off of what we've been doing for the past couple of days, what number do you think P is? 500, right? It's how much you start off with. The number outside the parentheses is always how much you start off with. Parentheses, 0.5 to the T. This is where it gets like the pre-AP part. It's confusing. It's not 2. The T says 2 days, but this T is not 2. What?
Can I say the answer?
Sure.
It's 1.95 for like 2.
So how do you know that though? Because you're right. The answer is 1.95. But
6 hours and 2 days. There's like 8. There's like 8 sections of 2 hours and 2 days.
okay. So
So
this,
it would
yeah.
be 8.
so this is what Kip is saying, and I feel like you're like he's kind of thinking about it differently. So maybe I can tell you it in a different way. So look at technetium. It takes 6 hours for it to lose half of itself. So we want to know how much would it take in 2 days. Well, so that's why 2 is not time. 2 days is, well, in hours, isn't that 48 hours? Because it's 24 and 24.
So time is 48.
So time is not 48 because it takes 6 hours per, like,
48
so that's why you would have, your time is 48 divided by 6. That's how Kip got, oh, there's 8 sections of 6 in 48. So when I type this in then, it would be 500.5 to the alpha y equals 48 divided by 6. Oh, you can say 8, but I feel like some of you just don't understand how I got the 8. That's why I want to show you. I got the 8 by doing 48 divided by 6. That's how Kip got 1.95. Okay, so let's do one more. So let's just do number 6 then, okay? So which equation can be used to find how much of a 50-gram sample, so that's how much you start off with, so 50, 50, 50, 50, it's right outside the parentheses, right? Of nitrogen-16 is left after 7 minutes. So so we know that it's going to be 50. We know it's going to be 0.5. It's the T that's confusing, right? So look at nitrogen-16. Nitrogen-16's half-life is 7 seconds. But I want to know how much it is in 7 minutes. Jose, do you think you know? It's not 1. So like F, G, H, or J. Jose said it was 1, but it's not. So it definitely is not F.
Wait, what are you asking?
So I'm asking you which equation it is.
Oh.
Rowan.
Yes. J.
Jay, it's 60. So remember, if you have 7 minutes, but you're comparing it with seconds, then 7 minutes is 420 seconds, and then you have to divide it by 7 because that's its half-life. That's how we got 60. Okay, isn't that kind of interesting? Like, so when you guys are like, when will this apply to my real life? I mean, in so many things, like you can do this in chemistry in high school. Like if you go into science and stuff, and of course, if you just want to be like, I don't know, I mean,